In this video, I'll share with you how to build a facial detection and recognition program in Python. This program will use a module known as OpenCV and another one known as face recognition. What will happen is you will submit some kind of image. This image will then be analyzed. It will detect all of the faces that are inside of the image and match them against any known faces. This is a really cool program, something that's relatively simple to build and create, and that you can run locally on your computer or that you could host on some kind of server. Now, before we get into that, let me just tell you that my name is Tim. I'm a developer advocate for Linode, and I run the YouTube channel Tech with Tim, which has hundreds of other programming tutorials. I hope you're looking forward to this video, and with that said, let's dive into it. All right, so let's go ahead and get started. Now, the first thing to do is just give you a quick demo. Then I'm going to run you through all of the code that will be publicly available from the link in the description and from my GitHub. Then I will show you how to write this code and run it locally. So as you can see here, we have a few different kind of scripts or directories. So I have client, server, and tutorial. Right now, we're going to focus on tutorial, which is what we're going to make in this video. And this allows us to run this facial recognition script, locally. So you can see here that I have a fair amount of code. And notice that I have a directory here called faces. Now, inside of here, I have a few different faces. So Bill Gates, Elon Musk, Jeff Bezos, Obama, etc., just a few celebrities. And then I have this test image that contains two people that we know the faces for. So if you see here, I am using my test image. I'm passing that to my classify face function. And if I go ahead and run the code by just bringing up my terminal, I'm just going to cd into the tutorial directory and go Python and then face recognition. You'll see that an image will pop up on the screen if we just give this 1 second that has the face recognition or the face classification. So it's identifying both Bill Gates and Elon Musk. And if I hit Q, then I can quit. So it's as easy as that to actually run this facial recognition script. You simply need some kind of image. In this case, we have our test image. You need some faces that you know. So in this case, we have 4 labeled faces. And then this script will be able to label any of those faces that it sees in some kind of testing image. So this here is the first way to run the script, which is running it locally, which means all of this is just happening on our own computer. The second way that I wanted to show you and at least include the code for is to do this in a server-client model or server-client way, where you actually have all of this facial recognition code hosted on some kind of server. Maybe this is a high compute machine. Maybe you just want to put all of this on a server so you can use it from a website or something along those lines. And then you have some kind of client that's going to access that server, send an image to it, and then get a new image back that will contain that classification. So really, we're going to do the exact same thing, except in this case, we're just distributing out the code so that we have the actual facial recognition code sitting on a server behind some kind of API, and then we have a client that we can use locally that's going to be more lightweight. So if you look here in these two directories, I have a server directory and a client directory. Inside of server, you can see that I have a simple API endpoint being hosted with a Flask web server. And then I have, again, this facial recognition script, which is just slightly modified to work a bit better with the server. Same thing though, I have my faces directory, and really it's doing the exact same thing. Then I have client. Inside of client, I'm simply accessing an API endpoint, which is classify faces. I'm going to send a test image to it, and then it's going to give me a new image back, which I can then display on the screen. So actually, right now, I'm hosting the server code that you just saw in this directory on a Linode server. If you want to do that yourself, then you can check out Linode from the link in the description. And I will actually have a GitHub repository that I'll show you in a second, which will kind of run you through how you would deploy this type of server code. Regardless, you can see that I have my server running here. And this is the IP address of my Linode server. So now, if I go to my terminal and I cd into my client directory, and then I go in lower cases, Python client.py, you're going to see that it will actually send a request to that server, and then I get a new image back that again contains the facial classification or the face recognition, I guess, whatever you want to call this. Okay, so hopefully that makes a bit of sense. But again, inside of the GitHub repository that will be linked in the description, you have your client code, your server code, and then the tutorial. The tutorial is what we're going to be writing, which will run locally. The server code is what will obviously sit on some kind of server, for example, a Linode server. And then the client code is what you could run locally. Obviously, you could change this. You could use JavaScript. Really, you can do whatever you want. I've just written a very basic Python client that will take an image, kind of convert it into a format where we can send this to our API endpoint. Then we will receive a new image back. We will convert this image, which is going to be a base64 encoded image, into a regular image where we can open that with CV2, which is a module that we're going to use, OpenCV, and then display that on the screen. Just to quickly show you this, if I go to my Google Chrome, you can see that I have a repository right here. This will be linked in the description. It has all of the code that you just saw, as well as a detailed README file that shows you how to install and set everything up, as well as how to run and change the code. And then if you want to deploy the server, you can have a look at this repository here, which shows you how to deploy a Flask server. So if you run through these installation steps, it'll show you kind of how to set this up on Linode. And if that is not helpful, then you can check out this YouTube video right here that actually shows you again how to deploy a simple Python web server, which is a Flask server. Hopefully that's going to be helpful to you guys. With that said, now let's actually start writing some of the code and seeing how we can set all of this up locally. All right, so I've just opened up a new VS Code directory here, and I've created a file called facerec.py where we're going to write all of our code. Now, before we can do that, the first thing we need to do is install all of the required libraries for this facial recognition project. Now, the first library we're going to install is CMake. So we're going to go to our terminal here. We're going to type pip install and then CMake. And if you are on Mac or Linux, you're going to type pip3 install CMake. So I'm going to go ahead and hit enter there. I do already have it installed, so this is going to happen no problem. Now, the next module we need is NumPy. So I'm going to say pip install NumPy. Same thing, I already have this installed, but for you guys, you probably need to install it. Now, after we do that, we're going to install a module known as dlib. Now, dlib is a fairly complicated module to install, and I did have some issues installing this previously. So because I can't necessarily predict what issues you are going to run in, I'm going to direct you back to this GitHub repository here, where it gives you kind of some setup steps for installing dlib. So if we just make this full screen here, I'll quickly run through it. To install dlib on Windows, you first need to make sure that you have Microsoft C++ build tools installed. Now, whatever the newest version is fine. I believe it's going to be build tools 2022. But what you need to do is click this link. It should download build tools for you. You're going to run through the installer. And when you get to the installer, make sure that you click this here where it says Visual C++ build tools, and then you tick Windows 10 SDK. If you do that, then you should be able to install dlib afterwards. Now, for some reason you're having issues with that, you can check out this Stack Overflow issue that runs through some of the common mistakes that can occur when you're installing dlib, and it gives you some ways to install dlib from source. Again, I apologize that I can't just give you a one-step command to do this. It can be a little bit complicated, so please kind of take some time, look through some different issues, and you should be able to figure it out if you are having problems by kind of going through this document here. Next, if you're installing dlib on Ubuntu or Mac, there is a good guide here that I followed that helped me install this. So again, click into this guide, kind of run through the different steps here depending on the operating system that you're on, and you should be able to install that. Okay, so hopefully that's going to help you guys install dlib. Anyways, once you get to the point where you've done all of the dependencies for dlib, you can type pip install dlib. This is going to take a second to install. For me, it usually takes a few minutes. And once that's done, then we're going to install the rest of the modules. Okay, so the next module that we need after dlib is face recognition. So we're going to type pip install, and then this is face _ recognition. If I could spell that correctly, I think that is fine now. Okay, so pip install face recognition. And then after we do that, we're going to install OpenCV and then -python like that. All right, so that is all we need for running all of this locally. Now, if you do want to actually set up a Flask web server, then you're going to need to install Flask. And if you want to have that Python client, then you need to install the requests module. That's all in the requirements.txt file from the GitHub repository. Okay, so now that we've done that, let's start writing a bit of code. So let me close this. And let's begin by getting all of our imports. So we're going to say import face recognition as fr. We're going to say import OS. We're going to say import CV2, which is OpenCV. And then we're going to import NumPy as NP, like that. Okay, so now that we've done that, we're going to create two functions. The first function is going to be get encoded faces. For now, we're just going to type pass. Then we're going to have another function, which is classify underscore face. And we're going to take in here a parameter, which is IM, standing for image. Okay. So now that we're here, let me just quickly run you through exactly what we need to do for this facial recognition project to work. Well, the first thing that we need to do is we have to have some faces that we know, right? If we know some different faces, then we can use those to actually classify faces that appear in some testing image. So that means that we need to create some directory here. That directory I'm going to call faces. And inside of here, we need to place some labeled faces of people that we know. Now, I've just gone with celebrities, but you can go with really any images that you want. But the type of images that you want to have here are very clear. They're the full person's face, usually some kind of headshot. That's going to be the easiest for our program to kind of detect. So let me just drag a few facial images in here. Obviously, you can put whatever you want, and then I'll be right back. All right, so I've just put a few faces in here. These are the same ones I was using before when I was doing the demo. And you can see that we have really clear headshots of the different people. This one's actually kind of more of a full body, but you still get a very clear, kind of nice, easy to see image. Now, notice that what I've done is I've actually labeled each of these images as what the person is in them. So I have Bill space Gates.jpg, and then it's a photo of Bill Gates. Whatever you put as the name of the image is what we're going to use to actually label or classify this face. So again, feel free to put as many in there as you want. Okay, so now that we have that, the first thing that we actually need to do is we need to read in all of these images and create something known as an encoding for them. Now, this encoding is essentially a format that this facial recognition module is going to use to be able to match this face against other faces that appear in other images. So we need to read them in, encode them, get them in this correct format, and then once we have that, we can use that to do our classification. So I'm going to create a dictionary here inside of this function called encoded, and then I'm going to read through this faces directory using the OS module and get all of my different faces. So I'm going to say for dir path d names, which stands for directory names, f names, which stands for file names, in os.walk, and then we're going to walk the /faces directory. Now, walking the directory gives us all of the directories inside of it, as well as the file names. I'm then going to say for f in f names. So I'm looking through all of the files. I don't really care about the directory name, sorry. I'm going to say if f.ends with, and we're going to check if it ends with a .jpg or f.ends with, let's spell this correctly, and then .png. So we're going to support both JPEG and PNG images. Those are the only two types that we're using. Then we're going to say face is equal to fr, which is our facial recognition alias, dot, and then load underscore image underscore file. And then the file we're going to load is faces/+f. And if we wanted to actually do this more correctly, we would go os.path.join, and then this is going to be faces and f, which is the file name. So we're going through all of the different file names. If it ends with JPEG or PNG, that means it's one of the face images that we want. So we're going to say our face is equal to load the image file, and we're going to load it at faces/ and then whatever the file name is. Okay, now that we have loaded this face, what we need to do is get the encoding for it. So we're going to say encoding is equal to fr.face_encodings, and then face, and then 0 like this. Now, the reason why we're going to index this at 0 is because we are going to get all of the encoded faces from the image using this function right here. So what this does is look in some kind of image, find all of the faces, and then gives us an encoded format of them. Now, in our case, we only have one face in every single image. It's important that we only have one face, by the way. If you have more than one, then this could potentially fail. So since we know that we have exactly one face, we can access the first face that gets returned from this list or array. Hopefully that makes sense. It gives us all of the encodings. Since we only have one face, we'll just get that one encoding that we want. And then we're going to say encoded. This is our dictionary right here. And we're essentially going to add this encoding in there with a label of what its name is. So I'm going to say f.split at period at index 0. This is going to be the face name. So if we want to make this even cleaner, we can say face_name is equal to this. So face name is equal to encoding. So we're just creating an entry in this dictionary that has the name of our face, which is really the file name. And we're removing, by the way, when we do this, the kind of extension, so JPEG, PNG, and we're associating that with the encoded format of that face. Then we're going to go here, and we're going to return our encoded dictionary like that. Okay, so now we have the first step done, which is encoding all of our known faces. Now we need to go into classify face, and we could call this classify faces, doesn't really matter, and we need to start writing the code here. So essentially what we're going to do here is we're going to look in a test image. We're going to locate all of the different faces. Then we're going to try to match any of those faces against the faces that we got from this function. So the first thing we're going to do is say faces is equal to get encoded faces. That's going to give us all of our known faces. We're then going to say faces encoded is equal to a list of the faces dot values. So this gives us all of the encoded face values, right? So all of those encoded types. Then we're going to say our known face names is equal to a list of our faces dot keys. So all of the keys in the dictionary are all of the known names that we have for our faces. Next, what we need to do is read in the image here. So we're going to say cv2 dot imRead, and we're going to read our image and put a 1 here. You don't need to know exactly what that's going to do. I'm going to say img is equal to cv2.imRead, and then we're reading in this image path. So really what we're passing here is just some path. We're going to read that in using cv2. And now that we have that, we can start using that face to actually, using that image to detect the different faces in. All right, so the first thing we're going to do is we're going to say face locations is equal to face recognition, if we can spell this correctly, and actually not face recognition, dot face underscore locations. And then we're going to pass our image. So once we have our image in a format from OpenCV, we can simply pass that to the face locations function, and that gives us all of the locations of our faces. Very easy. That's why we use something like the face recognition module. Next, we're going to get all of the encodings of these faces. So again, we now know where these faces are. Now that we know that, we need to get all of the encoded versions of them. So then we can use the encoded versions of the faces that we have in our test image and match those against the encoded versions of the faces that we know. So we're going to say unknown underscore face underscore encodings is equal to fr dot face underscore encodings like that. And then we're going to pass our image and our face underscore locations. Okay, so that gives us the face encodings. Now that we have that, we're going to say our face names is equal to an empty array. So what we're going to do now is we're going to loop through all of the unknown face encodings that we have. We are going to try to match them against the known faces that we have. And then anytime we locate a face, we're going to put it in this array. So we have some array that tells us, hey, these people are in this image, right? We'll also, of course, draw on the image who we think each person is. So we're going to say for face encoding in the unknown face encodings, and we're going to say matches is equal to fr dot compare underscore faces, and we're going to compare our faces encoded, which is this right here. So all of our encoded faces that we know with our face encoding like that. Okay, so again, that's why we need to do all of these encodings, because we need those two formats, or we need that format, sorry, to be able to compare the faces. Okay, so now that we have that, we're going to start and we're going to say the name of the face that we're currently looking at, right, is unknown because we haven't yet detected what it is. And if we determine what the face is, then we're going to change this name to be whatever, well, the face is. So we're going to say our face underscore distances is equal to fr dot face distance, and this is the faces encoded with the face underscore encoded. All right, so let me just take a step back here and quickly run through what we're actually going to get from each of these before I go any further. So first we have these matches, right? Now what we're doing is we're comparing the two faces. Now when we compare them, we're going to get an array back, which is going to give us true or false, indicating whether or not the face encoding that we have here for the individual face that we're looping through matches with any of the faces that we know. So in this case, we have 4 faces. So we might get something like false, false, true, true. Now, this might mean that facial recognition is telling us that it thinks the face that we're currently looking at is 2 different people. Okay, so that's why we're going to use this, which I'll talk about in a second. Anyways, it's just telling us whether or not it thinks the face matches with another face, it's possible that this might make a mistake. It might kind of indicate multiple people, for example, okay? So we have that. Now that we have that, we're going to get the distance between the different faces. Now, this works a little bit differently than our compare faces. What this is going to do is give us what's known as the Euclidean distance between every single face that we know and the known face. So we're going to use a combination of these two to determine if a face actually is what we think it is. So when this gives us the Euclidean distance, it's essentially telling us which face is closest to the known faces. The reason we're using both of them again is so that we first have this check, which tells us which ones we think match. Now, if for some reason we get multiple that match, then we're going to use the Euclidean distance to find the one that matches the most. Okay? So that's why I'm about to do the following. I'm going to say the best underscore match underscore index is equal to numpy, which is np, dot argmin, which is going to give us the minimum value from our face distances. So again, this is going to be an array that contains the number of elements equal to the number of faces that we have. This is going to give us the index of the position in that array that contains the smallest value, which would be the index of the corresponding face that matches the most. Now what I'm going to say is if matches at the best match index. Now what this is checking is if this here thinks that the best match index is actually a face that we know. Again, I know this is a little bit confusing, but this is returning us an array that tells us true or false if it thinks we're matching with a face. So we're only going to label something as a known face if it actually is a match here and if we have the smallest possible Euclidean distance, okay? So that's what we're checking. We're saying, all right, we found the face with the smallest distance. Is that a match? If it is, okay, then we found a match. So we're going to say name is equal to the known underscore face underscore names at the best match index. All right, then we're going to say face underscore names dot append the name, and we will append it whether it's unknown or we figured out what it is, just because this will tell us how many faces we have in the image in total, even if we don't know what that face is. All right, so now that we've determined all of the faces, or now that we know if a face is in an image and who that is, we want to actually draw that onto the image and then display that to the user. So to do that, we're going to have a for loop here, and we're going to say for top, right, bottom, left, and then comma name in, and then we're going to zip the face locations here with the face names, and we're going to draw our face name on the location of where that face is. So actually, let me just make sure I have the correct indentation. We're going to go out one level here because this first for loop is essentially identifying all of the faces that we have, which are going to correspond with our face locations. And then this for loop is going to draw all of those on the image once we've identified them. So here we're going to say cv2 dot rectangle, and we're going to draw a rectangle on our existing image, but we're going to draw it at left -20, top -20, right, and then, sorry, this needs to be inside of a set of parentheses, +20 if we can type this correctly, and then bottom +20, and then we need to define the color that we want to draw it. So I'm going to draw it in red. So this is red, green, blue, and actually this might be blue, green, red. I forget how it's done in OpenCV. We'll see what color this comes out as, but essentially we're putting some kind of BGR, BRG, or RGB value here. And then I'm going to put 2, which means a thickness of 2. Now you might be wondering, why am I doing this left, top, right, bottom thing? Well, essentially, this is going to give me the top, right, bottom, and left coordinates of where the face is, because I'm zipping my face location with my face names. So I get the face location, but I just want to expand it a little bit because the face location that is given to me by default by facial recognition is a little bit small. So I'm essentially going to take the left coordinate, subtract 20, and the top coordinate and subtract 20. Now, the reason why I'm doing this is because we need to have the top left and the bottom right-hand coordinate position for where we want to draw a rectangle. That's how it works. You pass the top left and the bottom right, which is what I'm specifying here for the coordinates in X, Y format. And then you pass the color and the border, and then you can draw that on the image. Okay, now we're going to draw another rectangle. So cv2 dot rectangle, again, on our image. And this time, we're going to have the left minus 20, the bottom minus 15, and then we're going to have the right plus 20, and the bottom plus 20. And the reason why I'm doing this is I want to draw a 5-pixel high rectangle, which is where we're going to put our name. Okay, so that's why I'm doing a second rectangle. Then again, we're going to have our color, so 25500. We'll have a thickness this time of actually cv2.filled, which means we're going to fill this rectangle completely in. And then we're going to actually put some text on this filled in rectangle. So I'm going to say font is equal to cv2.font, and then we're going to use this Hershey duplex font. There's some other fonts as well, but this is just the one that I'm going to pick for now. And then we're going to type cv2.putText, and we're going to put text on the image. The text is going to be the name that's associated with this face location. And then where are we going to put this? Well, we're going to put it in the same location as this pretty much. It'd be slightly different, but let me copy this in. So left minus 20, and then we're going to say bottom plus 15. Okay, and then we're going to say font 1.0, which is the anti-aliasing. And then we're going to put the color. I want the color to be white. So 255, 255, 255. And then we'll have this be 2 kind of pixels wide, or whatever you want to call it. All right, so let's just run through what we've done here, and then we'll actually draw this image onto the screen. So we have faces equals get encoded faces. We get all of the encodings as well as the known face names. We then have our image that we read in here using OpenCV. We have our face locations, so we get all of the face locations for our image. For the face locations, that gives us the top, right, bottom, and left-hand coordinate of where all of the faces are inside of our image. Then we're going to get all of the encodings from those different face locations. Then we create an empty array here called face names. Now, for every single face encoding in the unknown face encoding, so it's essentially all of the faces that exist in our test image, we are going to try to match them against the faces that we currently know. We're going to say that the name is equal to unknown right away because we don't yet know what it is. Then we're going to get all of the distances between the face that we're currently looking at in our test image and the faces that we know. We're going to find the face that has the closest possible distance. We're going to check if that is actually a match. If it is, then we're going to specify that this face that we're looking at has the name of whatever that match is. Then we're going to append that into our face names. That means when we get to this position right here, we now have all of the face locations as well as all of the face names, These are going to be matching up in terms of index 0 has a face location associated with index 0 of face names. So now we loop through the face location as well as the name. We start by drawing kind of a slightly larger version of the face, like a box around the face on the screen. Then we draw a filled in rectangle. Then on top of that rectangle, we are going to draw our text that actually says what the face name is. Perfect. Now that we have that, we're going to draw this onto the screen. So we're going to say while true, cv2.imShow. We need to give this a title, so I'm going to say image. We're going to draw our image onto the screen that we've already drawn all of this stuff onto. And then we're going to say if cv2.weight key1, and this is 0xff equals, and then this is going to be the ordinal of q. I know that this is really weird, but essentially this is going to tell us if we press the key and if that key was q, then we are going to return our face names, which will at the same time break this while loop. Okay, so that's going to wrap everything up. This is just going to draw the image that now has the face kind of labels on it. And then I'm just going to put something here that says if underscore underscore name equals underscore underscore main underscore underscore, then we will print classify underscore face, and we need to pass a path to a test image. So for the test image, I'll do test image.jpg. I do need to download this image still, and let's just make sure this is the correct name. So now let me get a test image. Let me put it in the same directory as my face recognition script, and then we'll run this and make sure that it's working. All right, so I've got my test image here, just the same one we were using before. Now we can try to run this code. So let's go Python facerec.py. Give it a second, and hopefully it should give us an image here that contains the face recognition. Okay, so we have an error here. Face encoded is not defined. Did you mean faces encoded? Let's have a look here. So this is right here. This needs to be face encoding, not face encoded, because we're referencing this variable here. All right, so let's give this another run. And there you go. We can see that our image pops up, and we have our faces labeled, Bill Gates and Elon Musk. Notice again that we have kind of this 2-pixel rectangle. We then have a thicker rectangle at the bottom, and we've drawn what the label is for this face in that rectangle. If we had a bunch of faces, it would label all of them. This is a pretty dynamic script. Now notice if you hit X, it's not going to quit. You have to hit Q, and then that will get out. And it tells us here that we have Elon Musk and Bill Gates as the 2 faces in that image. All right, so with that said, I think I'm going to wrap up the video here. I'll quickly kind of scroll through the code so you guys can have a look at it. Obviously, all of it will be available from GitHub in the link in the description. If you do want to deploy any of this code using a Linode server, then make sure you check out the GitHub repository. It has a link to a video, as well as another repository that kind of gives you some instructions on how to do that. Now, of course, you can host this on Linode, which is the best cloud provider, by clicking the link in the description and signing up for a new account. I hope that you enjoyed this video. If you did, make sure you leave a like, subscribe to the channel. I look forward to seeing you in another one.